Section 1.5 Electrical Safety. Electrical safety is the practice of preventing injury, equipment damage, fires, and other hazards caused by electricity. Electricity is essential in homes, workplaces, laboratories, and electronic systems, but it can be very dangerous when equipment is damaged, improperly installed, or handled incorrectly. The major electrical hazards include electric shock, the current pass through the human body, electrical burns, tissue damage caused by the electrical current or heat, arc flash or arc blast, sudden release of intense heat, light, pressure, and molten materials caused by the electrical fault. Fire, overloaded circuits, short circuits, loose connections, or damaged wiring can generate enough heat to start a fire. Equipment damage, incorrect voltage, short circuits, improper connections, or static electricity can damage components. The severity of an electrical injury depends on several factors, especially the amount of current, the path that current takes through the body, and the length of time the person is exposed. Even relatively low voltages can become hazardous under certain conditions, particularly when the skin or the environment is wet. Here shows the basic electrical safety rules. Turn off and disconnect power before working on electrical equipment whenever possible. Verify that power is actually off before touching conductors. Never touch exposed electrical conductors with bare hands. Keep water and liquids away from electrical equipment. Inspect cords, plugs, outlets, and test leads for damage before use. Use properly grounded equipment and appropriate circuit protection. Use the correct PPE and insulated tools when required. Never bypass fuels, circuit breakers, grounding, or other safety devices. Follow proper lockout, tagout, the LOTO procedures when servicing equipment. Know the location of emergency power disconnects and understand the appropriate emergency procedures. There's a popular question that's which one kill a person? Is that the voltage or current? Actually, the answer, or a more accurate answer, is both. It's the power. We're going to learn power in the next chapter. By definition, electric power is the product of voltage and current. But if the current goes through the body, and this is the cause of electrical shock, we can have very strong current but little voltage, so the power is not that large. Or we can have very large voltage but almost no current, also make power very small. So in order to kill the person is both large current and also sufficient voltage. That's the power. In this session, we talk about electrical shock. So the first figure shows the current goes through the upper body through the hands. If a person, such as one hand, accidentally touched the fire line, and the other hand touched the ground or the other side of the conductor, the current will flow from higher voltage towards the lower voltage, and then the travel path is indicated in this figure. Wherever the current goes through, that part of the body will be burned. And then the second figure shows the toes or the feet touch both sides of the circuit. So one foot touch higher voltage, and then the other foot touch lower voltage. The current will go through the lower part of the body. Therefore, the lower part of the body will be burned. And then the third figure shows left arm touch the higher voltage. The person is stepping on the ground or some kind of conductor. the current will flow through the hand, go to the arm, the upper shoulder, and then go through the lung to the body, pelvis, and then reach to the ground. So that travel path in the body will be burned or damaged. And then the last picture is even worse. The current goes through the left arm and then reach to the upper shoulder. However, it penetrates the heart and then continue flowing to the ground or the other end of the conductor. Among all these four cases, this can be the worst one, and most likely the person will be killed if the current is strong enough, because the current passed through the heart and burned the heart. This table shows the physical effects of electric current. Value vary depending on the body mass. Let's begin with the small current. If the current is barely 0.4 milliamps, the person can rarely feel it. And if it's about 1.1 milliamps, it's the perception threshold. When it reaches to 1.8 milliamps, the person can feel the shock but no pain, no loss of muscular control. If the current increases to 9 milliamps, there is painful shock, but still no loss of muscular control. When the current reaches to 16 milliamps, there is a painful shock and let go threshold. 23 milliamps, severe painful shock. The person experiences muscular contraction, also breathing difficulty. When the current reaches to 75 milliamps, ventricular fibrillation threshold. And if the current goes to 235 milliamps, ventricular fibrillation usually fatal for a duration of 5 seconds or more. When it reaches to 4,000 milliamps, the heart paralysis. 5,000 milliamps, tissue burned.